All right, so we're looking at the probability that our score is between 65 and 80%. Remember that we're given our information that it's normally distributed with a mean of 70% and a standard deviation of 4%. So in this particular case, if I were to draw my normally distributed curve of marks, we're told that our mean is 70. And we're looking for grades between 80% and 65%. And our standard deviation is 4, which means our first standard deviation would go up to 74, second would go up to 78, third would go up to 82. So 80 doesn't hit that value. One standard deviation below would be 66, and then two standard deviations below would be 62. So again, 65 and 80 do not hit the magical 1, 2, or 3 standard deviations away. So I'm going to have to figure out with the help of my z-scores. So I'm going to calculate the probability that 65% is less than x, which is less than 80%. Right? So I'm interested in this area of my curve. Well, we calculated in the questions above that the z-score of 0.65 is the same as minus 1.25. And the z-score of 80% was 2.5. So I know that the our solution to a z-score of 2.5. Trying to make sure here I got this. All right, so that's going to be really what I need to do is I want to calculate this z-score, right? Because that's going to be the area totally below 80. And then the reality is I don't want to include that. So I'm going to have to subtract this z-score there. You need to think about that a little bit. But when I calculate my z-score for my 80, or 2.5, that's calculating the area under the entire curve below 0.8. Whoops, but it's also calculating this red section. And I don't want to calculate that. So from my answer, I'm going to need to subtract this red part, which is really the z-score for my value of 65. You can take a moment to think about that, but that's showing that this is really the probability that my z-score is less than 2.5. Subtract the probability of the red section that my z-score is less than minus 1.25. And we calculated those answers above, which is 0.9938. Subtract 0.1056. And that yields 0.8882. So I can now say that the probability that my percentage, that the score is between 65% and 80%, is a 88.82% chance that that's what my scores will be. Finally, we'll do the last question. There's two more questions. A college admission test has a maximum score of 800. The mean score was 420 with a standard deviation of 110. Susan scored 695. What percent of those writing the test scored better than Susan? Now, we're not told that this is a normal distribution, but we assume that on a college admissions test, there's a large number of data points. So we will assume that the scores are normally distributed. So full solution would be to let x represent the test score. We're told that the test score that we're interested in is 695. So we want to know how many people scored better than Susan of 695. Our mean was 420. And our standard deviation was 110. At this point, a maximum score of 800 isn't important. I could go through and calculate percentages if I wanted to, but I don't actually need to. So to calculate a z-score representing a score of 695 on this test is going to be my z-score formula, x, my data point, subtract the mean over the standard deviation, which is x value of 695 minus my standard deviation of minus my mean of 420 divided by my standard deviation of 110, and this yields a z-score of 2.5. So we want to know percentage of those writing that scored better, meaning higher. So remember, this is my area here. I'm getting a z-score of 2.5. I'm interested in those people that scored better than that. So I'm looking above the curve. So my probability that my x is greater than 695 points is the same. I've correlated that to my z-scores, that z is greater than 2.5. And because it's greater, and our tables, remember our tables over here, give us values that are lower. All right, it's going at values that are lower here. So that means that we're going to need to take 1, subtract the probability that our z-score is lower than 2.5, because that's the data we have on our table. We already looked that question up, that value 2.5 up in the previous question. So that just becomes 1 minus 0.9938, which is equal to 0.0062. So I can say that the probability that my score is greater than 695 is going to be equal to 0.62%. So 0.62% of students, we would expect that 0.62% of students score better than Susan.
Okay.
Okay.
I'm doing my best to get you a calculus teacher. Are we going to really need one?
Well, I've just finished creating this video, so hopefully